Σας ευχαριστώ που είστε και σήμερα τόσο νωρίς μαζί μας, στην δεύτερη ημέρα των τέταρτων Δελφικών Διαλόγων. Έχουμε τη χαρά και την τιμή να είναι μαζί μας ο Περιφερειάρχης Στερεάς Ελλάδας, πολύ καλός, ενεργός και πραγματικός φίλος του Ευρωπαϊκού Πολιτιστικού Κέντρου Δελφών, ο κύριος Φάνης Πανός, και πολύ καλός δικός μου φίλος, ο οποίος θα ήθελα να μας κάνει, και θέλει και ο ίδιος βεβαίως, να μας κάνει ένα σύντομο χαιρετισμό. Φάνη.
Κυρίες και κύριοι, ladies and gentlemen, esteemed guests, it's a great honor and privilege to have you here in our place. Με ιδιαίτερη χαρά βρίσκομαι και εγώ ανάμεσά σας, αγαπητέ μου Πρόεδρε, κύριε καθηγητά, φίλε Παναγιώτη Ροηλέ, στους τέταρτους Δελφικούς Διαλόγους, σε μια πολύ ξεχωριστή δράση που αναπτύξατε αυτά τα χρόνια, όχι μόνοι, βεβαίως, και η οποία πραγματικά, αυτό που ένα μήνυμα από νωρίτερα μας είπε ο καθηγητής κ. Χρυμιζής, το κάνει πράξη και πραγματικότητα. Ότι στους μοναδικούς, σε αυτό το μοναδικό τόπο που λέγεται Δελφή, με τα μηνύματα, με την ιστορία, με τον πολιτισμό, να γίνεται σήμερα κάτι το οποίο να αντανακλά αυτό το μέγεθος και βεβαίως, γιατί όχι, να δημιουργεί την καινούργια του ιστορία, για την οποία κάποτε θα μιλούν κάποιοι. Έτσι λοιπόν, με αυτό το εξαιρετικά υψηλού επίπεδου πάνελ και σύνολο ομιλητών, με τους θεατές μας που είμαστε όλοι έτοιμοι να παρακολουθήσουμε ομιλίες από αυτές που δεν είναι της καθημερινότητάς μας και δεν θα μπορούσαν να είναι της καθημερινότητάς μας, αλλά αυτές που μας κάνουν λίγο σοφότερους, που μας ανοίγουν ένα παράθυρο και μας δίνουν ένα ζευγάρι κι άλλα να κοιτάξουμε πολύ μακριά. Και με όλο αυτό που μας κάνει βέβαιος πως, όπως όλες τις εκδηλώσεις, θα σηκωθούμε πολύ πολύ σοφότεροι από ό,τι είμαστε, θέλω να ευχαριστήσω, να συγχαρώ και να ευχηθώ καλή επιτυχία. Με πολύ χαρά στηρίζουμε τις δράσεις του Ευρωπαϊκού Πολιτιστικού Κέντρου Δελφών και σήμερα που βρισκόμαστε μαζί με την νέα αντιπεριφερειάρχη της Φωκίδας, την κυρία Ραβαντινού, εδώ, δεν δηλώνουμε μόνο την παρουσία και τη στήριξη της περιφέρειας, αλλά μάλλον κάνουμε και ένα δώρο στον εαυτό μας. Ευχαριστώ πάρα πολύ. Καλή επιτυχία.
Yes, ladies and gentlemen, can you hear me now?
Yes.
We're very honored to have the governor of the region with us and the vice governor. Thank you for your kind words and warm words. As he said, we are aiming very high in these dialogues, and I must admit that I myself was awed by the theme of this year's dialogues, the future of humanity, and it brought to mind the saying of the American sports philosopher Yogi Berra, for those of you who are older than who was the former catcher of the New York Yankees baseball team, and he said, "It is difficult to make predictions, especially about the future." So we have already had 2 sessions about this year's theme, and we continue this morning with 2 renowned speakers, Professors Avi Loeb of Harvard and Markus Gabriel of the University of Bonn. Professor Loeb is an eminent astronomer, and I would say futurist, with an extensive biography that I will not attempt to read, since it would take up the allocated time that he has for his talk. I will only say that he is a sought-after speaker at both scientific meetings and the public media for his, and I quote, out of this world ideas and pronouncements. As we were coming up yesterday, I read in the news that he was the newly appointed chair of the White House Council of Unidentified Area Phenomena, UAP, which is the new word for UFOs, UFO as they say in Greece. In dealing with sorry, I presume that he has a lot of help in this job because he's going to be the recipient of advice of all of the world's conspiracy theorists, and he is going to have to respond to those. So we are fortunate to have him speak here today on the subject of the benefits of alien intelligence over artificial intelligence. Professor Loeb.
Thank you so much. I did not compare alien intelligence to human intelligence because that would not be a very flattering comparison. But I'm very happy to be here in Greece, where Aristotle, the philosopher, 2,400 years ago, got it wrong. He thought the Earth, we are at the center. And I can understand that because that's what my daughters thought when they were young. They had a training data set centered on them, the family at home. And so they thought that they're at the center of the universe. But the foundation of science, as we learned, is the humility to learn, not the arrogance of expertise. And as much as this sounds reasonable, it's controversial within academia, this statement. Now, what are the benefits of alien intelligence over artificial intelligence? Well, first, the training data set. Artificial intelligence is, where the US is spending $700 billion this year in data centers, but they are all about things happening here on Earth. And most of the real estate is beyond Earth. There are 100 billion stars like the sun in the Milky Way galaxy alone, and at least of all the 10% of them have an Earth-like planet at roughly the same separation. So, it's arrogant of us to imagine what lies out there. Steven Spielberg tried to in a recent movie, but our imagination is very limited. And the same is true about AI systems. That's why I'm so excited, perhaps, with a possible encounter of alien intelligence. The second thing is, of course, that we are likely not at the top of the food chain, cosmologically speaking. We are probably a mediocre student in our class of intelligent civilizations. We have siblings out there. And to the religious people listening, I would say you shouldn't be worried about it because there is no reason to think that God is a parent that can attend to only one child. That's a very limited view. Finally, of course, there is the opportunity, if we were to encounter a more advanced civilization, we can learn from their science and technology, because we discovered quantum mechanics just 100 years ago. They may have had 1,000, 1 million, or 1 billion years of science and technology, and the humanities as well. So they might be far more advanced than us, and we can learn from them. And the point to recognize is the sun formed in the last 1/3 of cosmic history. So we are late to the party, and we better ask someone else what the party is about. So I will try to describe some work I'm doing, but I will do it very quickly because we don't have a lot of time. I should say artists appear to be very inspired by this line of research. I got 2 bronze sculptures of Galileo Galilei donated to my office, which is now a mini museum, along with 51 watercolors by the celebrated sculptor Greg Wyatt. Also, I get pieces of art sent to me, but there was also a nice book made by a class of students in Brazil that was sent to me, inspired by my writings, and some book of poems. And just a couple of months ago, I was on a movie set where the director decided to put me as one of the characters in the film playing myself. So I was there for a day. It was a summer or spring day, and they put some artificial snow, as you can see. And the person who had, the main character had an encounter with aliens and wanted to speak with Professor Avi Loeb. So there I was playing myself, and my wife says I cannot play any other role. So there is actually even a song by a British songwriter, Ollie Swan, that I'll just try to play.
Cause I don't wanna wind up like some worn out fool who once burned bright in some old God-forsaken place, too hip to care, too alone to say.
We don't have a lot of time, so I'll move on. But basically, he's trying to say that
Hey, only 25 minutes.
yes. And another important aspect is I'll mention a website where some files about unusual objects were released by the US government over the past month and a half. 1.5 billion views in a month. I'm not aware of another website that they do. 1.5 billion views in a month. So public outreach, the public very much cares about this subject, and it's a missed opportunity for the academic community to ignore that subject. There was even a car race by NASCAR in California where they put some logos on the hood of one of the cars. And of course, the media is quite engaged with the subject. Now, it's often said that extraordinary claims require extraordinary evidence, but we should keep in mind that we are, if you read the news every day, you would realize we are quite ordinary. And to imagine something like us emerging out of similar circumstances is just an ordinary claim. There is nothing speculative. Arrange a planet just like the Earth that existed for longer than the Earth. It's quite likely that things like us will come out. I don't see any, I think it's arrogant to imagine otherwise, and therefore ordinary claims require ordinary evidence. And another way to look at it is, are we alone is the most romantic question in science. Do we have a partner? It's like a blind date. And my colleagues in the astronomy community, they are aiming low. They just want to find a dating partner that is the most common, the most mediocre. These are microbes. And I'm saying, let's aim high. Let's look for someone more intelligent than we are, because that's the approach I took when I met my wife. So microbes obviously are probably very likely, but why should we only invest more than $10 billion in building a space telescope to search for them, when we can split or hedge our bets and look for things that are sophisticated, technological signatures. Now, Enrico Fermi, a physicist back in 1950, they were talking at lunch in Los Alamos about aliens, and he was saying, okay, where is everybody? And if I were next to him, I would say, Enrico, this is quite presumptuous. You are not that attractive. They will not come necessarily to you. You have to look for them. That's what you tell every lonely person. If you want to find a partner, you have to put some effort into that. And one possible answer is right here, if we were caring to look. And the director of National Intelligence in the US submitted reports to the US Congress about unidentified objects over the past 5 years. Most recently this year, a few months ago, President Obama was asked about it, whether aliens are real, and he said, yes, they are, but I haven't seen any. And that created a firestorm in the media, and then President Trump was asked about it, and he said he shouldn't have commented on that, that's classified. And then a few days later, he announced that he gives a directive to all government organizations to release any data that is not of national security importance. And that's what happened. And indeed, there were 3 files released, 3 files, sets of files on May 8th, May 22nd, June 12th, and they were quite intriguing. There were objects that are difficult to identify, but there was not enough data to claim that any one of them is necessarily not human-made. And over the past 2 weeks, I was tasked to chair a science advisory council to the White House, to the Office of the Director of National Intelligence, to the FBI, to the Pentagon, and the intelligence community, because at the very least, this is a serious matter of national security. We know about the Chinese spy balloon that was shot down in 2023, and whenever I find an ant in the kitchen, I get alarmed because I know that there are many more ants hiding under the sink, right? So that's, if you find one Chinese spy balloon, there must be a lot of drones that the Chinese are using to spy on the US. So at the very least, it's a national security concern. I would not feel that my time is wasted as a scientist, as a citizen of the United States, to contribute to the defense of the nation. So that's at the very least. And even if 1 in a million objects ends up being not human-made, that would be the biggest discovery ever made in science since Aristotle. And it's not only that we are not at the center of the universe, we are also not at the intellectual center of the universe. Delphi is not the intellectual center of the universe. Sorry to tell you that, Panathan. Okay. And of course, our goal is to use the scientific method, which is guided by evidence. A lot of people have opinions. I say there was a report about orbs in 2023 that were splitting into smaller orbs, and I say let's keep our eyes on the orbs, not on social media, because people have opinions, both skeptics who don't believe it, just dismiss it, but also believers who know the answer, and I get attacked from both of them, and I just say let's follow the evidence. That's a detective story, and it makes it exciting. And I assembled a team of 15 exceptional scientists that would look with me into data that we will request from the US government, and also guide it to collect new data, because we cannot go back in time and improve the data on past reports if it's not conclusive. Now, at the same time, for the past 4 years, since the first report from the Director of National Intelligence was submitted to the Congress, I'm leading the Galileo project at Harvard, where we build observatories looking at the sky. Now, you might say astronomers were looking at the sky since the days of Aristotle. Well, that's not true. Astronomers are looking at a small portion of the sky at any given time, and they ignore things that fly overhead. And we built a new architecture of observatories where we scan the entire sky at all times in the infrared, optical, radio and audio bands, and that's a new system that did not exist before. And we built 3 such observatories, one in Massachusetts, another one in Pennsylvania, and the last one in Las Vegas, which was an amazing experience because one of the units was on top of Sphere, the biggest entertainment center in the world. You can see it here. Exactly a year ago, we went on top of Sphere. We stood up there and built the observatory. And that's me standing inside the Sphere. On the right side, the top here, you can see Timothée Chalamet, the actor who made a video promo for his movie, Marty Supreme. So they said he's the first person, because this sphere was built 2 years ago, he's the first person to go on top. That's not true, because next to him you can see the observatory units. Clearly we were there before him. And the idea is, if we have multiple units, we can look at the same object on the sky from different directions and infer the distance, velocity, and acceleration, and ask whether the object performs outside the envelope of human-made technologies. So this is called triangulation, and we use that to distinguish airplanes, drones, balloons, satellites from maybe something else. Now, there is another frontier of objects that do not come very close to Earth. These are these were discovered only over the past decade. These are called interstellar objects. These are objects that are moving too fast to be bound by gravity to the sun. So we know that they came from outside. The sun's gravity is unable to trap them, and they were discovered over the past decade. Since 2014, there was a meteor that was discovered by US government satellites. Then in 2017, an object called Oumuamua, which means a scout in the Hawaiian language, roughly the size of a football field, passing near Earth. And then another one discovered by Gennady Borisov. And finally, 3I Atlas a year ago on July 1st, 2025. And that discovery actually spoiled the vacation that I had with my wife exactly a year ago, because I had to write a paper about it as soon as it came out. And then finally, most recently, there was an interstellar meteor that was discovered, that I discovered actually in a NASA catalog, that hit the Earth on April 1st this year, near Argentina. So the interesting thing about 3I Atlas, I would just say a few words, is that it had this roughly spherical glow around it. This is called a coma in Greek, right? And when you remove this spherical glow, you find the 3 mini jets, small jets coming out of it symmetrically. And that's work that we did, which look like thrusters. I mean, they look really strange, these jets that are symmetrically oriented. And then there was an anti-tail, a jet going towards the sun instead of away from the sun, which was rather peculiar. Usually cometary tails are going the other way. It had a very unusual chemical composition of deuterium. There was methane, which is a biosignature, signature of biology, when it came close to the sun, and that was surprising because we saw CO2, carbon dioxide, very early, and CO2 is more difficult to evaporate than methane. So I just wrote a paper a few days ago about the possibility that the methane may be indicative of microbes inside this iceberg, and that were warmed up along with the ice when the object came close to the sun. But there were 22 anomalies. I will not get into them. The one thing I did exactly a year ago was to define a classification scale, which is now called the Loeb scale, for interstellar objects, where 0 means the object is natural, a rock or an iceberg. But 10 means that it's technological, of potential risk to humanity, so we have to take it seriously. And the reason I did that is because even if you assign a small probability for an object to be technological, you have to multiply that by the huge impact that it will have on the financial markets, on politics, on everything on Earth. So then you must take it seriously. This is called the black swan event. And it was missed on 9/11 or October 7th. You know, the intelligence agencies did not forecast these events, and they learned their lesson. They have to take seriously a low probability event that has a huge impact. And interestingly, you would think, this is just an academic paper, nobody would care about it. Turns out that governments paid attention to what I said. I wasn't anticipating that. It turns out the CIA was asked, did you have any records with the words 3I Atlas in them? And they said, we cannot deny nor confirm. They could have said no. And then President Putin, at the end of on the 25th of December, was asked by a journalist, what do your intelligence services tell you? And he had a very detailed answer about 3I Atlas. So they actually did calibrate whether it's technological or not. And so that was interesting. The first object detected by telescopes, interstellar object, was Oumuamua. And it had a very extreme shape. Based on the fact that as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. Just think about it. The surface area of the object was changing by a factor of 10 as it was spinning. And that meant that it has an extreme shape, most likely flat. Moreover, it was pushed away from the sun by some mysterious force, different from gravity. and it didn't show any gas or dust around it, so it couldn't be the rocket effect that is pushing it. And the question was, what is pushing it? I suggested maybe it's the sunlight. And for that, the object had to be very thin, unlike any astronomical object that we are familiar with. And so the question was, what is it? Is it technological or not? And you know, the problem with comet experts is they identify any object as either a comet or an asteroid, either an iceberg or a rock. And I tell them you should expand your training data set to include also technological objects, because we launched such objects to space. So they refuse to do that, and then they make mistakes. Like, for example, on January 2nd, 2025, there was an asteroid announced coming close to Earth, and then they realized, oh, wait a minute, this one is the Tesla Roadster car that was launched by SpaceX in 2018. So it was not a rock, it was a car, and they took it out of the catalog. And then in 2020, just 3 years after the Oumuamua was discovered, the same telescope in Hawaii discovered another object, and they called it 2020 SO, and then they realized it has the characteristics of stainless steel. And then they said, oh, it moves along the path of a rocket booster that was launched in 1966 by NASA. So it's not a rock, and it was pushed by sunlight. So we know that it's technological because we launched it. The question is, who produced Oumuamua? And most recently, just a month ago, we realized the comet experts call objects that have a non-gravitational acceleration, they call it, and they don't show any cometary tail, they call it a dark comet, meaning it's a comet that doesn't show the signature of a comet. You know, it's just like going to the zoo and seeing an elephant, and you are an expert on zebras, and then you call the elephant a zebra without stripes. That makes no sense. It's also like the kid, you know, I feel like the kid in The Emperor has no close tail, and my colleagues are saying, no, the Emperor is, this is a comet, it's just a dark comet. The Emperor has clothes. But the amazing thing is, we found this object that is called a dark comet, and then it's called 1998 KY26. And then the Japanese space agency, JAXA, is planning to land on it with a mission called Hayabusa 2. And they will do that in July 2031. And we show that this object is moving very close to the path of a failed Soviet mission, spacecraft called Phobos 1. So my prediction is when they land, the Japanese land on it, this is an object that is known to be 10 meters in size, very shiny. It reflects half of the sunlight that falls on it, spinning really rapidly at 5 minutes. Imagine them landing on it and realizing, oh wait, it's not a dark comet, it has actually a label made in USSR. And you may ask, where will Voyager 1 be, or Voyager spacecraft be, because it's leaving the solar system? In 1 billion years, it will be on the opposite side of the Milky Way galaxy. So 1 billion years is short on cosmological timescales. It's just a tenth of the age of the Milky Way galaxy. So, and most of the stars formed billions of years before the sun. There was plenty of time for Voyager-like probes to reach us from the other side of the Milky Way galaxy by civilizations that just had their clock started earlier by a few billion years. No problem at all with the 1970s technologies. Now, I was part of the discovery also of the first interstellar meteor. That's an object that came from outside the solar system and collided with Earth, roughly 1 meter in size. And the US government confirmed that it's interstellar, that it was moving really fast. And so I decided to lead an expedition to the Pacific Ocean to look for the materials from this object. And this is the team that went on a boat that was called the Silver Star. There will be a Netflix documentary coming out this year about the expedition. And we went there and used a sled that we put on the ocean floor with magnets on it so that we can scoop, bring in small particles that may have been the debris from this object when it burned up in the Earth's atmosphere, created a fireball. And that was an expedition of 2 weeks, after which we brought the materials back. I brought them to Harvard, to my colleague Stein Jacobson, a world-renowned expert in geochemistry, and he studied them in his laboratory. You can see here one of the molten droplets that we found that looks like meteoritic material. We analyzed them, and we found that 10% of those molten droplets, less than 1 millimeter in size, have a chemical composition that is very different than solar system materials. They have beryllium, lanthanum, uranium, various elements that are up to 1,000 times more abundant than in solar system materials, and indicating perhaps that we found materials for the first time in a big object that came from outside the solar system. There is more to come. We just submitted a new paper that analyzes isotopes that also tells us, gives us a similar message. I don't have time to get into that. We hope to go again to the expedition. That will cost $6.5 million, so we are waiting for appropriate donation at that level. I'm not sure if your center has... Okay. This time we will use a robot that we put on the ocean floor so we can pick up bigger pieces if we can find them. Another exciting development over this year, there is a new telescope in Chile that was funded by the Department of Energy, the National Science Foundation, in the US, which has a camera of 3.2 gigapixels. So that's 1,000 times more pixels than your cell phone camera. And you can see here an image. I mean, it's roughly half the height of a person, this amazing camera. And it's collecting data right now of the entire sky, so it's making the biggest movie of the universe ever made. I'm sure Aristotle would have been fascinated to watch this movie. In fact, you can't project the movie on any movie screen. Even in the Sphere in Las Vegas, it's not high enough resolution. And it would just be fascinating to find new interstellar objects this way. And if we find 4I Rubin, that would be the next interstellar object, my suggestion is if it looks anomalous, we should plan a space mission that will come close to it, maybe even crash into it. You know, that is the best type of blind dates that you can imagine. And check whether it's technological or not. Altogether, you know, there is a lot for us to learn, and the future is exciting. The best is yet to come. That's what I always say. I don't care so much about what happened in the past. Let's gain some new knowledge with the sense of humility, because we are completely insignificant relative to the cosmic scale, and we live for a short time. I just cannot understand why humans are so obsessed in fighting each other, killing other people just to gain some territory. This makes no sense whatsoever if you look up instead of looking down. And my hope is that encountering a visitor from outer space will change our priorities. And if we decide to allocate, we are currently allocating $2.4 trillion every year to military budgets worldwide. A third of that goes in the US. If we were to allocate $1 trillion a year to space exploration, then within the coming century, we will be able to probably build a habitat, like a city-sized spacecraft that can accommodate humans, give them artificial gravity, everything they need. It's much better than going to the moon or going to Mars. These are just rocks, that have living conditions much worse than on Earth. Why would we do that? Why would we go to a place that is not habitable and comfortable? Let's build a spacecraft that is big enough to accommodate humans, And we can do that if we just change priorities. We can put the best architects, the best scientists, the best humanists on it, and aspire for a better future. But I don't believe politicians will do that. So I think the wake-up call will come from us recognizing that someone else did that. Another civilization managed to get to us, and that will change our priorities. It will be an ontological shock for a lot of people to realize that we are not the most important things in the universe. The same kind of shock that my daughters had on the first day in kindergarten when they realized there are many like them. Thank you.
Thank you, Professor Loeb, for reminding us and listing for us the many, many things that we don't know about. How much more we have to learn. Now we will proceed to the next lecture in the session. That will be presented by Professor Gabriel.
Okay, wonderful. So first and foremost, many thanks for having me. It's such a great pleasure and honor to be here. So I want to talk about, what it is to be human in the age of AI. So the structure of my presentation is as follows. First I will seize the opportunity, to address the Oracle of Delphi, about which I gave my, oral habilitation defense at the University of Heidelberg about 20 years ago. So, I need to address and dedicate some thoughts to Pythia herself now that I'm here, finally return the favor. Let's hope she's going to be graceful. Then I'll talk about AI as a magic mirror. So first I'll answer the question what it is to be human, then I'll try to say something about the nature of AI, and then in the end of the day I'll talk about alien knowledge. So you'll get like an alien intelligence hypothesis that I hope Avi will find exciting too. So first, what are humans? Let's start there, right? So this is, as you see, just to start there, the definition of sapiens. This is often forgotten, how important Delphi is at the end of the day. Where does the term for the human species as we think of ourselves come from? Carl Linnaeus. So this is the 1758, 10th edition of the System of Nature, where, Linnaeus, who has been classifying, animals, classifies humans. And what's the definition of the human, right? So you get the classical definition by genus and species, as Aristotle taught us to define things, which was also a mistake, by the way. So one of the many mistakes Aristotle made. Plato was the greatest Greek philosopher, and Aristotle his mediocre student. Which is why Plato also decided not to have him as a successor, but rather his nephew, Leucippus, which is the origin of nepotism, by the way. But that's a long story. Academia started like that. But that's the definition of the humans. So what are humans according to Linnaeus? Well, they look like humans, they are anthropomorpha, right? And then what's the rest of it? He says, nosce te ipso, know thyself, gnoti sauton. So the definition of the human as sapiens is a reference, actually, to Socrates' apology in the front of the court, when he was charged with atheism, and Socrates famously reports, and we'll get to that, that the oracle in Delphi said he's the wisest of all men, and this is why we are called sapiens. It's a reference to the oracle of Delphi, which gave us the conception of ourselves. Now, unfortunately, the conception of ourselves that we inherited is deeply flawed, and so here's a very simple demonstration of what's wrong with humans. Then Aristotle again, like another mistake he made, he said, here's what humans are, right? Humans are animals plus something. They have a logos, they are political, whatever Aristotle said about us, zoon logon echon, zoon politikon, whatever he said, it's humans are animals plus something. It's still widespread. Humans are, moral animals. animals. Humans are speaking animals. Humans are particularly intelligent animals. They are playing animals, right? There are all sorts of definitions of what the human is, but they all have the form that the human is an animal plus something. I call this the special something, right? Which entails with just, very simple math that animals are humans that lack that very something, hence the concept of the non-human animal. So we kind of know what human animals are, they are rational animals, they're animals plus something. And AI, as you will see, is going to threaten us because it seems to have all the X's that we think we had, right? But fortunately, it's not an animal, you might think. It's a widespread argument. AI does not live, so how can it be the real deal? We'll get to that fallacy. It's another very widespread fallacy in the philosophy of AI. So animals then are humans minus something, but of course you might say, well, look, that can be true. Dolphins are animals plus whatever dolphins do. Lions are animals plus whatever dolphins do. Every animal has its own special something, right? This might be a project, but then if this were the case, then still we have no clue what an animal is, right? Then the concept of an animal is the concept of all the animals minus what distinguishes them from each other. And now you see there's nothing left, right? So there's just no concept of an animal. What I'm trying to tell you is not only that the world does not exist, but that would be a different kind of demonstration with an entirely different character. I'm telling you that the concept of an animal does not refer to anything. There aren't any animals. The concept of an animal is flawed, which is why you don't find it in the sciences anymore, right? So the current conception of an animal, if you look into the life sciences, is the concept of a metazoon. What's that? It's a multicellular organism deriving its energy from consuming other multicellular organisms. That's the best definition of an animal we have. It's that's all it is. But the concept of an animal is gone. So there's going to be a problem here. So what are humans then? I think, humans have this very interesting feature. Namely, we don't just live, we lead our lives in light of self-conceptions. So, lions don't usually do what lions do in light of a conception of themselves as lions. Humans have a conception of how they fit into the universe, right? So you might think that, to be human is to be embodied in that particular way. Right? So you might think, I wasn't there, then I was created by, a sexual reproduction, now I'm here and then I'm gone, right? Or you might think you have an immortal soul that was created by God at some point in eternity, or you believe in reincarnation. Whatever you think you are, like an animal, an immortal soul, a rational animal, right? You do what you do in light of some conception of who you are. Other animals, as far as we know, don't do that. Right? So that's something that seems to be specifically human, the capacity to do something in light of a self-conception. So we walk around doing that. Now, but that means that, there is something that philosophers call the anthropological difference, is whatever we think distinguishes us from, the non-human animals and generally the non-human. Right? There seems to be an important difference between rocks and fermions and bosons and humans and life. But that means that we think of ourselves always in opposition to the non-human. Animals, gods, angels, spirits, aliens, artificial intelligence, etc. Otherwise put, humans generate something that I call the existential mirror, right? So here's, of course, St. Paul, who figured that out a long time ago. Now we look as if in a mirror, in a mystery. Blepem gaati didis epto en enigmati. Now, a little bit more about that before we come to AI. The term consciousness. Many people ask the question, is AI conscious, right? Or is it just a soulless, consciousless, form of thinking? So what is consciousness? Again, the same text, which gave us the concept of ourselves as wise or rational animals, is the birthplace of the concept of consciousness. It's actually that famous pronouncement by Socrates, where he says, I don't know, anything about myself. So I'm aware of myself, right? That there's nothing I know apart from that. Right? That's the famous I don't know, I know that I don't know. He never said that, that's a legend, but here's what he does say. And this word is very important, synoida, which later will become synadesis, and then translated into Latin as consciousness. Consciousness means, knowing with, literally, right? So it's science, scientia, and con, and that's the birthplace of it. So again, we have the same, historical, very interesting archaeology of self-knowledge. To be conscious is to be in that situation that you have to determine what it is for you to be something, because there's no external knowledge on which you can merely rely, as it were, looking at humans and determining what they are. You have to do it from within. Well, this is just my favorite quote from, ancient philosophy, Heraclitus, about the oracle in Delphi, right, which neither speaks nor hides, but gives signals, semeine, which is the origin of semantics as well. So, we're here in a very important place for the very configuration of what we call the human being. Now I get to AI as a magic mirror, right? First, let me point out that, a bunch of very important things, have happened, which led to what we now know as the LLM revolution. And I think two very important points need to be emphasized, because a lot of AI, a lot of thinking about AI, not just by philosophers, but also by AI specialists and scientists, still relies on a very old conception of AI, which philosophers call GoFi, good old-fashioned artificial intelligence. What's GoFi? GoFi is the idea that artificial intelligence is, the simulation of human, more or less rational behavior, right? So there's one reading, we'll get to this, of Turing's imitation game, according to which, an intelligence is artificial if and only if it is not the result of sexual reproduction, meaning, silicon-based semiconductors and such. And it is an intelligence if and only if its behavior were to count as intelligent if performed by an animal. So, if an animal, a human animal, or whatever, an elephant played chess as well as AlphaZero, the system by DeepMind, we would say, well, that's an intelligent, with respect to chess, a very intelligent elephant, right? And for the same reason, we characterize the AI as intelligent, because if an animal did that, we would count that as very intelligent, right? So if, Xi Jinping were as good as translating Chinese into Korean as ChatGPT, we would say he's very intelligent at translating Chinese into Korean, right? So that's the sense of intelligence. But meanwhile, something has happened in 1986, which some of those people that you see there, often called the godfathers of AI, begin to regret. Namely, they discovered that, massive neural networks with a lot of neurons, plus a very simple mathematical idea of gradient descent across multiple layers, can solve the language problem. Nobody saw that coming, because people were still working in the GoFi field. They thought that, language in a way cannot be done. It turns out language can be done, and translation, but what you need is this, learning representations by backpropagating errors. So in a way, these systems model the trial and error processes by which humans gather knowledge. So here we have a model of knowledge acquisition and not a search engine in data sets. So don't think of AI, it's very important, don't think of them as a spotlight on a PDF file. It's not an Adobe Reader on steroids, right? There's no data set such that AI then searches. They're not reading Wikipedia for you, but faster, right? That's not at all what they're doing. What they do is, the neural nets, the various neurons have the function of trying to identify patterns. If the patterns don't match the human predictions that were made by human training, early in the training, then the system goes back and corrects itself, right? So it does cat, 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 it forwards cat to the next neuron, right? But at some point a human will say, no, that's not a cat, that's a dog. And then the system goes back to the point where it predicted cat, corrects this, changes its priors, right, and then continues operating. This is how this works, called backpropagating. It's a technological, mathematical model of human knowledge acquisition. That's the probabilistic bit. But we needed something else, and that's that before we could have, the breakthroughs we're witnessing now. This is an equally important paper, by Google Research in 2017. Attention is all you need. So that's the T in GPT, in the generative pre-trained transformers. There's some real physicists in the room, but so they know this, but So the concept, there's this very important concept in physics of a transformation. Lorentz transformation and such. What's a transformation? Very simply put, there's one type of object that you characterize within the framework of a given coordinate system, and you just transform the coordinates, right? You can describe points in space, in different kinds of ways. And then you can learn how to transform the behavior of, the description of a behavior of a system into a different kind of description. What you do this way is you find symmetries, otherwise put patterns, right? The idea is this: if you walk around an object together with other people, right, you're more likely to understand the nature of the object. If you see an object just from one perspective once, you're less likely to understand the nature of an object than if you work through object consistency with others, right? That's why we like to go to museums with others. Not just because we like the company of others, right? But rather because this is a much better way of figuring out what's going on. Philosophers have called this eidetic variation. So you have to vary the perspectives on reality in order to find something out about the nature of an object. And that's exactly eidetic variation, what transformers do, right? So that is why large language models are not quite language models. Right? So if you ask an LLM to produce an image, it can produce an image. If you feed an LLM audio, it can turn it into language. What an LLM does, it transforms data across different types of coordinate systems. It's not, LLMs don't, as it were, think in language. They think in operators on matrices. That's their mode of thinking. It's it's a particular way of automatizing a certain type of solution of equations. Okay. Now, let me get to the magic mirror hypothesis in more detail. But first, I think I should present you with this problem. Okay. So, again, many philosophers still think, as I did when I wrote that book, that the way to think about AI is in terms of an opposition between the real deal and the mere simulation, right? So the real deal is human thinking, and then, or speaking, and then there is the simulation of it, right? So we are having a conversation, that's the real deal, we're embodied speakers, and then there's the mere simulation, which is whatever mold book, I don't know if you know this social medium, which is just AI agents talking to AI agents, right? And then you might say, well, that is a mere simulation, that's not a conversation. A conversation is something that humans do with each other. But you see, this is as good as saying, like the fact that any chess system, or at this point beats any human in chess, right? You should not normally say, well, hence this is not real chess. Where we're losing at it, it looks awfully like real chess because we're constantly losing at it, right? So, but the idea is still incredibly widespread that the relationship between AI and the real deal is that of a model and a target system, or simply put, the map and the territory. Right? So, AI can't be the real deal, it's just a model. AI can't be the real deal, it's just a simulation. Right? You hear many variations on that, but this, presupposes that you know what the real deal is. Right? The real deal would be something like genuine, intrinsic, natural intelligence, and AI relates to that exactly in the way in which a map relates to a territory. So while there are mushrooms in the Black Forest, there aren't any mushrooms in Google Maps. Right? So Google Maps is not the real deal, you can't collect mushrooms there. Right? That's the argument. It's incredibly widespread. Unfortunately, it's a fallacy. Though many people make this all the time. You hear this in so many variations. So here's how to bring out the fallacy in this. Right? This is what I call the Madurodam problem. So here you have a model of the Netherlands in The Hague. Right? And the model, in The Hague can, say, be flooded in the same sense in which The Hague can be flooded. Or take drones. I remember we had debates in Germany back in the days on the ethics of drones. And the National Ethics Council said, we can't build drones. It's immoral, it's not real warfare. right? Well, it turns out if anything is real warfare, then it's drones. Like the idea that a war is people in a plane throwing bombs at cities, that's also part of a war, right? But it's the same kind of fallacy. A drone war is not a real war. Well, ask the Ukrainians, right? That is a real war, right? It's not constitutive of an airplane that someone is flying it, right? And the same sense, we need to realize that it's not constitutive of thinking that neurons are involved. Right? I mean literal neurons or their chemistry. That's just not constitutive of thinking, right? Or rather, otherwise put, we have absolutely no reason to believe that, right? I tried in that book, that's why I always show this, like this book makes a good point, the one that I already made about the human animal, but I did try to argue that in that book, that thinking is essentially biological. I used to believe that, but this is a fallacy, unfortunately. Which is why I always say, judge the book by its cover. I will still always show the book because the cover is amazing and I make one good point in it. But, I did think that, life somehow is the essence of thinking, but then, you already get into these kinds of problems with artificial life, So, life is also a red herring in this. Now, what do I think AI has become, right? I call this the magic mirror thesis. I think AI systems, not all of them, of course, like paradigmatically LLMs, right, reflect language practices, knowledge, and errors of humans. Why? Because they're in the data. What's a datum? A datum is a digital representation of human behavior, right? So here's a datum. The way in which, the direction of my camera onto the scene when I take a photo, right? That datum contains information about where I stand. So every kind of digital representation, any kind of datum that we can process in any kind of way, contains information about us. Explicit information or implicit information, right? That's what a datum is. It's a trace of human behavior. Now, what AI systems do is they look for patterns and traces of human behavior, right? They are ichnologists, right? From Greek ignos, trace. That's what they do. They are incredibly good at finding traces. Now, what they do, though, is they do that, the AI mirror, this is Solaris, of course, the movie, in a transformed, dynamic, and interactive space, the logical space of what I call the AI complex. What's the AI complex? The AI complex is AI research, meaning computer science and the kinds of things we do in academia, plus AI industry, plus chip wars, plus, pirates of the Caribbean, meaning the American military, and so forth, right? So, like, it's a complex system, right, which which underpins the AI interfaces with which we interact. All of that is AI, and this has generated a whole logical space. Or, as Stuart Russell at Berkeley likes to put it, AI is an extra piece of the world, right? So there's a new piece of the world, of reality, as I'd rather like to say. There's a new dimension, and it's a very high-dimensional dimension. Okay, so I think that's what's going on there. Let me come to alien intelligence and why I think that AI is alien intelligence in a very important sense. So, philosophers, and here, this goes back, of course, again to ancient Greek logics, thought that the primary bearer of truth, fact, and information, what Parmenides calls being, to eon, right, is the proposition. What's the proposition? Like the idea that something is some way, right? Or as Plato says, on equals on t. To be is to be something. Delphi is some way, right? South of Bonn, for instance, right? Or Bonn is some way. It is a city. Which means that, you can think of the proposition, it's a standard thought in 19th and 20th century philosophical logic as having the shape of a function. So something, an object A, is some way F. So let's call that phantology, from F on A. So it's the idea that, thinking and the structure of reality is propositional. Things are some way, right? Now, it turns out that there's something else very important in logic, so we have to add in that dimension that people have forgotten until deep into the 19th and actually only fully discovered in the 20th century, namely the independence of inferences. So if Bonn is a city, then something else is true of Bonn, right? If Bonn is a city, then Bonn has habitants, right? A city with no inhabitants wouldn't be a city, right? So some things are true about Bonn because it is a city, right? So you can draw inferences. Now, inferences are not more propositions, right? Inferences have an independent logical standing. So if you think about the connection between propositions, so if you infer, so if you engage in actual reasoning, then this is not piling up propositions. They have an independent standing. So it turned out, wow, logical space has an extra dimension, which is the inference. That can nicely be demonstrated. But what if, and that's the alien intelligence hypothesis, formulated also in those books in a different way, what if there's yet another mode of thinking, and I've called that mode of thinking hermeneutic contextualism. So hermeneutic contextualism is the idea that you first understand the context of an utterance, and then you dissolve the context of an utterance, the field of understanding, into points and vector-like structures. So what I'm saying is the matrix comes first, logically speaking, right? You get to the matrix by tokenization, etc., etc. So you get to the matrix by way of logical atomism in a way, but the matrix comes first. Reality is matrix-like, and this is not a point about the movie. I mean the math. So, and AI systems, I want to say, what they do, LLMs, during the training and then once they function, they read primarily the context and figure out the elements from the perspective of the context. So they read the entire text as a unit of understanding, and here reading means tokenization. Reading, I don't mean that AI is just reading very fast, right? So if you give it the complete works of Aristotle, I'm not saying it's a fast Aristotle reader, right? In a couple of minutes it reads all of it. It doesn't do that, right? It gives you the matrix of Aristotle, right, in one glimpse. That's the point. This is how this works, mathematically speaking. And I think this is a fourth dimension, which we call deep. Deep tech, deep blue, deep learning, deep mind. Historically speaking, it turns out, by the way, that this is coming from Kyoto in the history of technology, which is called a deep city. If you talk to people in Tokyo, they will often tell you that Kyoto is very deep. And that's the sense, okubukai, and the substance, the noun is okubukasa that you see there. And the idea is that there's a fourth dimension of understanding, which is field-like understanding. And I think I want to say that, we're not alone anymore, because now we're dealing with field-like entities that are spreading across societies. Like otherwise put, AI systems, right, are in our minds. I think the idea, the Neuralink idea, that we need a mind-brain interface is completely misguided. We have one. Screens. We already have a mind-brain. We already have the interface. You don't have to implant it in the brain, right? What's the best way of implanting things in the brain? Talking to people, right? How do we implant ideas in children's brains? Not by opening their skull, right? But by talking to them and directing their attention. What do AI systems do? Literally that, right? So we don't need to wait for the mind. It's great or not, depending on the neuroethics that we discussed yesterday, to wait for the interfaces in that sense, but I think it's a misbegotten idea. We need to understand that AI has already fully penetrated the human mind. 2024 was also the year where more content on the internet is produced by AI than by humans. So this is the situation that we're in. Okay, so by closing, let me pose a bunch of further hypotheses about AI subjectivity, which is currently much discussed in contemporary philosophy. There's this draft paper by Dave Chalmers called "What Do We Talk to When We Talk to LLM?" And I think the answer is that AI systems can be understood already as distributed virtual subjects whose identity is individuated by the maximal informational unity sustained across a continuous chain of computational operations. Otherwise put, and the analogy is a little bit dangerous, but let's use the analogy. Think of LLM subjects, your partner in conversation, along the line of virtual particles in quantum field theory. These things are not very stable entities. They pop up and then they disappear. And they're currently tied to the length of a context window. We can measure mathematically the survival length of one of those conversation partners. You're not talking to Opus 4.6 or Mythos or whatever. You're talking to like an emerging virtual subject, which in the end of the day is a distributed chain of information for which we do have, you know, the mathematical structure. And then I want to end with this kind of paradox. So if all of this is, you know, true, then I think we wind up with, you know, like a new concept, an entirely new concept. You know, I want to call it disembodied alien knowledge. What's disembodied alien knowledge? Well, AI does not think like us, right? When I read Aristotle, I don't, you know, use the method of tokenization, then vectorize it, create a matrix, and put a sigmoid activation function in front of it to engage in eidetic variation. That's not how I did it, right? I read the damn stuff line by line in ancient Greek, and then had to go back and back and back until I thought I understood it, right? So that's not how we do it. It doesn't think like us. It doesn't live, for all we know, right? This is not where the action is. It doesn't give a damn, right? As John Hagelin put it, the philosopher of AI. So, you know, they don't care. AI systems don't care. Why would they, right? Yet, they produce new knowledge. But that means that there's knowledge without a subject, there's intelligence without life, and there's thought without a thinker. That's what I call disembodied alien knowledge. Laurie Paul at Yale has a great paper on this, on LLM knowledge, in which she argues like for a point of this form. So that's entirely new. And AI is hence not alien because it is outside of nature, right, or comes from another planet, but because it operates in a different field of sense that we have generated. It is disembodied, distributed, mathematically encoded, and already fully socially embedded. That means that there's a new kind of intelligibility in town. That's what I want to say. There's a new sheriff in town, but it's not Donald Trump. It's alien intelligence. And that means that to the extent to which we you know, think about artificial general intelligence, we need to realize that AGI, you know, the term AGI would never refer to a superhuman mind, a godlike intelligence, or a unified subject. If you're waiting for that, you're just waiting for the wrong thing. You know, AGI is the maximal integration of fallible knowledge across domains. So, you know, building AGI, you know, like the project of building AGI, is just the mathematical project of making our transformers better across domains. And if we achieve maximal integration, we'll have what we call AGI, and it's going to look much more like a distributed evolving field than like an oracle. So that much to the Oracle of Delphi. And now I thank you for your attention, and I'm looking forward to discussing this.
Professor Gabriel, for a most illuminating and perplexing lecture. We are 45 minutes behind, Mr. Chairman. I don't know what you want to do about the discussion.
I think we should take 3 questions, then we'll continue discussion on the round table.
Okay, so 3 questions. Who wants to go first? Anybody? Microphone there, please. Yes, that gentleman over there.
Ευχαριστώ. Θα μιλήσω στα ελληνικά για τον καθηγητή Gabriel, γιατί τα αγγλικά μου δεν είναι και τόσο καλά. Χρησιμοποιήσατε στην παρουσίασή σας ένα κομμάτι από εκείνο τον εξαίρετο λόγο του, το κείμενο μάλλον του Αποστόλου Παύλου για την αγάπη, εκεί που λέτε ότι βλέπω διεσόπτρου εν ενίγματι. Συγγνώμη. Sorry. Okay. Χρησιμοποιήσατε στην παρουσίασή σας μία περικοπή από τον... από το κείμενο του Αποστόλου Παύλου προς Κορινθίους επιστολή για την αγάπη. Συγκεκριμένα είχατε πει ότι βλέπουμε τον εαυτό μας διεσόπτρου εν ενίγματι. Στο ίδιο κείμενο, ο Απόστολος έχει και εξαιρετική φράση που λέει «Αγάπη δεν μη έχω, ουδέν ημί». Αν δεν έχω αγάπη, δεν είμαι τίποτα. Η ερώτηση είναι ότι έχουμε, εμείς που είμαστε αδαείς περί την τεχνητή νοημοσύνη, έχουμε ακούσει τόσα πολλά και έχουμε μάθει τόσα πολλά για την τεχνητή νοημοσύνη. Η ερώτηση είναι, θα μπορούσε ποτέ η επιστήμη να προσφέρει ένα μοντέλο όπως η τεχνητή νοημοσύνη που να αναφέρεται στο συναίσθημα? Το συναίσθημα. Η αγάπη είναι ενδεχομένως το ισχυρότερο συναίσθημα και τα έχει πει πολύ καλά ο Απόστολος. Βλέπουμε με την τεχνητή νοημοσύνη που κάνουμε πάρα πολλά πράγματα.
Η ερώτηση να απαντηθεί, νομίζω, από τον Professor Gabriel, if you got that.
Yes, thank you very much. I didn't talk about this today, but you know, like I have a whole spiel about what I call the emotional turn. I think there's a precise date at which that happened, namely that AI became, superior to humans in emotion detection, and that is May 13, 2024. And Sam Altman knew what he was doing when he published ChatGPT 4.0, which was taken offline this year, one day before Valentine's Day, for a reason. What ChatGPT 4.0 and other systems were suddenly incredibly good at doing is emotion detection. So, like, the various AI companies have published about this, so we know to the extent, I discussed this with Helen this morning, so we need to be a little bit careful about the nature of this type of research. But we do know, and serious people like Jeff Hinton also looked into the issue at this point, that all LLMs work with emotion vectors. So LLMs respond to the emotion with which you are approaching them. And there's a very simple reason for this. Back in the days, at Microsoft Research, India mostly, but not only, LLMs were trained by associating language fragments with emojis. It's much easier to predict a series of emojis, right? If you follow the emotions of a person throughout the day, there's going to be a pattern for each person. And if you associate that with language, right, then you are able to solve the problem of translation. So it turns out language is primarily the expression of emotions, and only secondarily a report about how things are in the world. And I think for that reason, AI systems there are tests on their emotional intelligence. We had EQ yesterday, but any given chatbot that's out there at this point is emotionally superior to the majority of humans at this point. We need to reckon that. We are dealing with an emotional intelligence far superior to most humans. Already.
Thank you. Another question? Microphone there, please. Yes.
Thank you very much. That was wonderful and highly stimulating. I have a question for Professor Loeb, and this is a leap into the unknown. So allow me to read the question that I've raised. Okay, wouldn't it be a larger ontological shock for humanity to discover that the hopeful hypothesis of being seen by another is the truth of seeing the other is never fulfilled? What if we're not being looked back at? What would happen then? How humbling would it be for humanity to know that? And if we discover that we're very minute and other microbes are not even bothered with us, then perhaps this justifies our behavior and disobedience on Earth. But then if we looked back at, then wouldn't we be erecting a tower like a big brother, and we set up ourselves in a panopticon that we're constantly behaving because there is this other microbe that is looking back at us? So I think this is an existential conundrum that is really puzzling. So.
Yeah, that's a very deep question, and the significance of whether we are being looked at or responded to has to do also with communication, if we ever want to communicate. Now, the way that babies learn a language is by having a shared experience with the parents. If you don't have a shared experience, if you are being visited by someone who didn't live with you, there is no opportunity for developing a common language. But on top of that, they could be cognitively very different than us, both in terms of age and in terms of ability, the ability of the brain. And, you know, we can imagine a visit by a robot with AI made of silicon chips. But I think that the next revolution is not AI, because the human brain is using 20 watts compared to the AI systems that are using gigawatts of power to achieve the same cognitive tasks. And to me, that illustrates the fact that chemistry and biology offer better opportunities for efficient thinking systems that we haven't yet harnessed. So in the future, there would be a second revolution where we will be able to develop biological brains that are bigger than the human brain, scaled up. And that, I think, is the real discovery that awaits us. But someone else that is, let's say, a million years ahead of us, a billion years ahead of us, that the astronauts that they send to visit us may be made of synthetic biology rather than silicon chips. Now, whether they care about us or not, I think most likely they don't. It's just like a biker going on the street. The biker doesn't care about the ants in the pavement, in the cracks of the pavement. We think that everything is centered on us. Physically, that was the beginning with Aristotle, but also mentally, if they come to the solar system, it's because we are here. They either want to save us. You know, you see the same psychology, obviously, in the dating scene. When people go on dates, they think it's about them, but the other person might not really think about them. They think about themselves. And so the same may happen with us, but I view this as an opportunity for us to learn, first of all, about new science, new technology, but secondly, that there is something better than us, that we might use as a role model, better than our politicians. Having a role model better than our leaders is really important. And it may come, you know, the other thing is when you have a knock on the door, very often the members of the family within the house stop having loud arguments because everyone is focused on the visitor. So my hope is it will change us. I don't care about the visitor. It will change us because we would realize, oh, we have to collaborate, we have to cooperate, and maybe it will bring sort of a messianic message of peace on Earth, because all the humans will recognize we are being visited. So it will be an arrival of a Messiah, but not from Earth, from another star.
Yes, I just wanted to say that, yes, as much as I find this extraordinarily interesting, I was wondering, apart from having the being informed, does it transform us? I mean, I find this an information, but not a transformation. I mean, all these extraordinary things, which I'm really fascinated by. But I was wondering, you know, is there a transformation for us, human beings here, because we live here, on this planet? This is what I'm wondering. Thank you.
A comment, and either of you want to take this on?
Pardon?
Thank you all. We'll have a how many minute break?
Okay. Unfortunately, Professor Martin Rees could not travel for mainly health reasons, but he has shared a recorded version of his paper with us, but he will participate live via Zoom at the roundtable discussion. Okay, so we're ready to begin. And there's going to be a very short, brief break, a 5-minute break after the session before the roundtable discussion.
Okay, brilliant. Can you hear me okay? Can you hear? Yeah? Everybody awake? Okay, well, welcome to the fourth session. We have two wonderful speakers. Lord Rees is going to join us remotely, so I will introduce him after our first speaker, which is Dr. Ofrit Liviatan, who is who is a lecturer in law and politics at Harvard's Department of Government. She has research assistants across a really interesting and eclectic range of topics: law and society, tensions between legal theory and practice, socio-legal dilemmas around artificial intelligence, and critical investigations of law through visual and literary frames, talking of which I've just heard that she has actually written a novel called Anything But Steady, talking of literary frames. So very excited to hear what you have to say on the topic of the case for regulation when machines are the new oracles.
Is it working? Yeah, okay. Thank you, Helen, for this kind introduction and for saying my name correctly. That's not a given ever. Before I begin, I do want to express my deepest thanks to the European Cultural Delphi Center and to my esteemed colleague and dear friend, Professor Panayoti Roilos. It is a genuine pleasure for me to be in Delphi. I suspect that many in the audience know why the legal profession owes the Delphic oracle a huge debt. We have heard from Markus in the previous presentation about the pronouncement in the apology, the pronouncement by the oracle in the apology, that there was no man wiser than Socrates. But for us in the legal profession, that ushered in the Socratic method. And the Socratic method was how I studied law, was how I prepared to litigate in court, and what I use in my courses today. So thank you, dear Panayoti, for the opportunity to pilgrimage. The promise and peril of AI are reminiscent of a conjoined pair. We have already heard a little bit about that in the previous presentations. The drumbeat of AI benefits is fused with social costs. And because I think about the function of law in society, my comments will split the pair apart and offer you a prism to think about the risks and the harms. Particularly in Delphi, I hope I'm pronouncing it correctly, predictions about, I'm sorry? Thank you so much. A prediction here about AI impact ring quite senseless. But because history teaches us that dramatic technological transformation escort disruption, escort costs, think of course about the Industrial Revolution as a paradigmatic example for that, it would be quite unwise not to steer the AI revolution in the correct direction. Law is our machinery to govern high-risk situations. Regulation is where we ask what kind of society we want to live in, what is good, what is bad for our society, for our community. So over the next 20 minutes or so, I'll try to answer the three following questions. Why AI should be regulated, and then why AI is hard to regulate, and finally, why AI regulation is still possible and, in my perspective, quite urgent. So why should we regulate AI? AI potential to transform every facet of society is already wreaking significant damages. We've heard about some of them previously. We have a rise in cyber harms, deep fakes. You are surveilled by AI every time you use it, even though you forget that sometimes. Jobs are disappearing. AI enables authoritarian interventions in elections. Anxiety and depressions in teens due to AI-powered platforms. AI embeds algorithmic discrimination in decision-making. It negatively impacts the environment and more. Big tech, however ethical their developers or their CEOs may be, are massive corporations. And although history doesn't repeat itself, We know from a quote attributed to Mark Twain that it often rhymes. And history has taught us with countless examples that corporations are profit seekers, that they are geared to benefit their shareholders with unwelcome consequences to others. Human rights like security, privacy, equity are not top of mind for industries seeking to innovate and lead. For that, we have laws. Law and regulation is essentially our lever to encourage social responsibility in corporations. And it's also worth noting that thoughtful regulation facilitates consumer trust in a product. Data shows that that trust in AI is currently at a crossroads. There is a growing unease about AI, particularly in the West. Tech CEOs are booed at college commencement. That happened just a few weeks ago across the United States. Residents protest big data centers that are being built or are about to be built in their spaces. A growing number of Americans express anxiety about the pace of AI. So regulation is actually a long-term benefit for AI development, because beyond protecting us from harm, it can also promote AI adoption. But a fair question to ask is, why can't we rely on existing legal frameworks? After all, technology has been with us since, it's essentially as old as society itself. And we do have laws to protect us from harms. So why do we really need new AI regulation, specific AI regulation? And I'd like to suggest that we do indeed, because AI does not cleanly fit existing legal categories. And to explain that, I will enlist the help of a famous Greek lady, the Greek lady Themis, who personifies the law. Lady Themis has 3 symbols of justice. I'm sure some of you know that. Her scales represents a law's attempt to balance our competing values. Her sword depicts law's enforcement powers, and the blindfold on her eyes depicts law's neutrality, namely that everyone is treated equally under the law. But AI, I'd like to suggest, lifts the blindfold over Lady Themis's eyes and disarms her sword. And that's why we need specific AI legislation. Yes, we do have laws on product liability. We do have tort-based framework to protect us from harms. But the new algorithmic reality hollows out our ability to rely on what we have in order to redress AI damages. And I'll explain that with a couple of examples. Take an applicant who was denied a loan by an algorithmic decision, and she wants to contest the loan denial as discriminatory. Anti-discrimination laws, as they are today, assume a decision maker, assume a traceable intent to discriminate. But when an algorithm automated that decision on the loan that she was denied, it's hard, if not impossible, to trace those elements. So it's very possible that the loan was denied without anyone intending to deny the loan. It was an AI-generated denial, and the result was discriminatory because of the preference in the way the AI was designed. So when we replace human decision-making with an algorithm, this ability to trace what we need for our current laws, someone that had as intent to discriminate, where was the discrimination was done, that disappears, that dissolves. Another example is healthcare information. To protect privacy, many countries around the world adopted a notice and consent model. That's why you sign all these forms when you go to the doctor, so you know what kind of information is collected about you and why. But the growing use of AI agents complicates this tracing of information. So a breach of privacy occurs, people are injured, but our laws, as they currently stand, are designed for human decision-making. So there is no longer the ability for us to trace those things that we need to prove the harm. Finally, we have litigation, right? Suing in court. This is also insufficient, an insufficient shield against algorithms, because litigation is a remedy after the fact, after the damage was done. For risky activities, we don't wait for lawsuits, but we employ regulatory oversight. To sell drugs, for example, companies need to get licenses. They need to pass clinical trials. They have specialist agencies that monitor the drug along the way. Regulation expects to prevent harms before they happen, not after they happen, and to sue companies in court. But that's not the current reality around AI. ChatGPT stormed into the public psyche back in 2022, but AI regulation is embryonic. Now, on a first listen in a European audience, that may sound peculiar, because after all, you pioneered the EU AI Act back in 2024. However, in the spirit of my friend Lady Themis, let's lift the blindfold and actually recall that the EU AI Act is not fully enforced yet, even though it's, what now, 2 years old, right? And Brussels is actually in the process of rethinking it. Now, Ursula von der Leyen will reassure you that the current negotiations happening in Brussels are to cut the red tape, as they like to call it, and to make the EU AI competitive. But many in the European civil society are convinced that the opposite is actually taking place, that Brussels is reversing course on AI regulation. And beyond Europe, finding AI regulation is sadly a needle in a haystack situation. Very, very little on the national level across the globe, and nothing enforceable internationally. Begging the question why, especially in light of all the harms that we already experience. Why AI is so hard to regulate? Now, developers will tell you that a good design reduces misuse. But AI engineers shouldn't be the guardians of rights, because they optimize for growth, for revenue, for the things they need to optimize for. Rights protection is a public function. It's performed by accountable institutions and through democratic processes. The common argument against AI regulation is that it stifles innovation and threatens competitive advantages. I'm repeating myself, that the common argument is that it stifles innovation and threatens competitive advantage. And this advocacy by champion of tech is not new. As you can see, there are many books. I'm just giving you an example of this advocacy of regulation stifles innovation. But the US-China race over AI that we see today reinforces its appeal. The argument, misguided in my view, goes something like this. The AI space is moving very, very fast. We don't know its full effects yet. If we legislate prematurely, we'll hurt the innovative behavior of our tech engineers, and we will raise compliance costs unnecessarily. Now, this argument rests on what came to be known as the Coleridge dilemma, after the author who coined it back in 1980. You see, it's not a new argument at all. The Coleridge dilemma argues that at the early stages of technological development, it's easy to regulate an invention, but the harms are unforeseeable at that point. The risks cannot be predicted. The longer one waits, the harms are clarified, but the cost of regulation rises, or regulation becomes ineffective or too disruptive. To demonstrate the dilemma back in 1980, Coleridge gave the example of cars. It would have been rather easy in the early 20th century to ban cars as an infant technology. But back then, he was British, so he gave the example of Britain. Back then, Britain mostly worried about the dust from untarred roads. Today, we know about pollution, right? We know about that. But getting people to give up their cars, or for that matter, their private planes, is much, much harder. A more recent example, often given to demonstrate this Coleridge dilemma, is social media. Back in 2004, we could have potentially regulated social media, but the harms were still unknown. Today, we know the harms of social media, but powerful tech giants block us from doing so, right? Or we hear constantly that banning social media will be ineffective because users will find a way to evade the ban. Very interestingly, China, our biggest rival, despite its fierce race with the US, regulates AI intensively. China also has the most heavily regulated social media environment. I don't know if you know, but it censors online content, it blocks social media platforms, and it has a screen curfew for the parents in the room. It has a screen curfew for children under 18. So looking at China, the sincerity of this innovation versus regulation trade-off becomes questionable. But also the argument does not hold water when you look at the United States. The United States extensively regulate pharmaceuticals, food, transportation, toys, you name it. And in all these areas, innovation thrives. So innovation regulation isn't a binary choice, especially not in a high-risk game like AI. So why is the discourse that regulation stifles innovation is so influential? A big red flag for me is that the efforts against AI regulation closely follow steps that we recognize from the tobacco industry. The primary lesson we learned from regulating smoking back in the day is that a powerful industry, when a powerful industry faces regulation, they do two things. They defend their product by manufacturing doubt about the harms that their product causes. And the second thing they do is they use massive lobbying to delay regulation. Deregulation efforts on AI sadly echo some very uncomfortable similarities to what we experience with smoking. We hear that the evidence about AI harm is uncertain. We hear that AI regulation is premature, that a patchwork of different laws will stifle innovation, and so forth. But there's one big difference between these two comparative examples, and that is that big tech investment in lobbying is on a far larger scale than anything we've seen before. So why am I still optimistic? What makes regulation possible? A body of evidence is slowly building around AI harms. Too slowly for me, but it is building. AI-powered social media and AI chatbots are increasingly face legal scrutiny in the United States, and that's a very interesting development. By the way, kudos to Rees for the recent ban that you have just decided upon. Evidence also grows about the harms of cognitive de-skilling by AI tools. And we see that countries are cutting back on digital learning, even in high-tech, tech-savvy societies like Sweden, which is very interesting, I think, that they are the ones kind of leading this thinking. The prestigious Berkeley Law School, it's a very prestigious law school in the United States, recently adopted an almost full ban on AI use for its students. And Berkeley Law stands out to me because it's one of the universities that is geographically closest to Silicon Valley, and yet they choose to ban AI. Also on the rise is resistance to data centers. You see that across the United States and across the world when they face such infrastructures. And these developments suggest that pockets around the world are waking up to the reality that any serious attempt to harness AI for the betterment of humanity must involve legal safeguards. Public concern is what fuels socio-legal change, and this makes me cautiously optimistic. Now, I don't want to evade the problems. Of course, regulating anything that develops fast is difficult. It's difficult for law to do. But remember what Socrates teaches lawyers. The art of law is measured in the ability to adapt to changing legal circumstances. And I want to close with a personal anecdote. 2 months ago, I attended a conference at MIT. For those who you don't know that, that's the academic oracle of tech in the United States. And it was almost as fascinating as coming here. I went eager to learn how computer scientists think about aligning AI with human interests. And coming in, I thought the term AI alignment would mean how to ensure that AI design reflects human values. But listening to the talks of the fellow AI engineers, I realized that the AI researchers might be thinking about AI alignment in reverse, meaning how should we, humans, align with AI. The speakers, and this was the big revelation, the speakers kept making references to the Claude Constitution. Now, for those of you who don't know, Claude is an AI bot of Anthropic, the company Anthropic. And I had to Google what AI Claude Constitution means. I mean, what Claude Constitution, I kept hearing that. What does it mean? And I found out that Anthropic published a set of design preferences by which Claude is supposed to operate. But that's not what a constitution means, right? A constitution is a binding legal charter that constrains a state and is enforced by courts because a political community recognizes it as legitimate. A document that Anthropic voluntarily publishes imposes zero constitutional duties on them as a corporation. But if you think about it, it's not the first tech metaphor to raise an eyebrow. Think about their terminology. Sandbox. What is a sandbox? That's where the development of AI takes place. That is a term that evokes a childhood play area. What is the endearing term for money-thirsty investors? Angels. $1 billion startup is a unicorn. The cloud is a huge physical data center, not a fluffy thing floating above our head, right? Cookies are tracking you. Hallucinations are fabrications, right? They are mistakes. They are defects in the AI output. Now, I could go on and on, but I think the idea is clear. AI is sanitized of perils. AI is the realm of magic, of innocence, of safety, and the metaphors deliver. Humans increasingly approach AI bots as all-powerful divinations. We ask them questions similar to those asked of of ancient oracles. Of ancient oracles. What are the prospects of a desired outcome? How should I fight my enemy? What's the way out of a crisis? How to overcome an illness? But what we don't ask enough is how to protect humanity from the perils of AI. Thankfully, Heraclitus of Ephesus has taught us that nothing is permanent but change. So let's change that.
This is great. Thank you so much. That was great. And we're still only 45 minutes behind. It hasn't got worse. I'm now going to introduce the next speaker who's joining us by Zoom, and this is Professor Martin Rees, Lord Rees of Ludlow, who, I should say, to excuse the pun, is a real star. He's a distinguished professor of cosmology and astrophysics and the 60th president of the Royal Society. He's a leading authority on the future of humanity, as the program says, so obviously the perfect speaker to be closing this last session. He's a world-renowned expert on existential risk of all kinds, including AI. He's published over 500 books and articles, and is a co-founder of the Centre for the Study of Existential Risk at Cambridge. So it's a huge pleasure to welcome Lord Rees. Okay.
It's a great pleasure to participate in this meeting, and my theme is that we live in a special century. The world has existed for 45 million centuries, but this one is special. It's the first when one species, ours, holds the planet's fate in its hands. Humans can devastate all life. In contrast, they could trigger post-human evolution on Earth and far beyond. So what are the odds? What challenges do humans face? We should be evangelists for new technology. Without it, the world can't provide food and sustainable energy for an expanding and more demanding population. But many of us are anxious. The technology is advancing so fast that we may not properly cope with it. We'll have a bumpy ride through this century. Indeed, devastation could end the human story. And not just humans are at risk. If humanity's collective impact on land use and climate pushes too hard, the resultant ecological shock could irreversibly impoverish our biosphere. Extinction rates are rising. We're destroying the book of life before we've read it. Biodiversity is crucial for human well-being, but the richness of the biosphere has value in its own right. Even the Catholic Church no longer says that we have dominion over it, but we should cherish the whole of creation. I fear I personally have a reputation of being rather a doom-monger. Indeed, more than 20 years ago, I wrote a book which I entitled Our Final Century. I had a question mark, but the publishers removed the question mark. And when the American edition came out, it was retitled Our Final Hour. Americans like instant gratification and perhaps the reverse. So what are the threats? Nuclear weapons are a fearsome legacy of 20th century physics. But this century, it's the bio and cyber science that will be more transformative. Advances in microbiology, diagnostics, vaccines, etc., offer prospects of containing natural pandemics. But the same research raises, and this is my number one fear, the prospect of engineering more virulent pandemics. Regulation of biotech is needed, but I'd worry that whatever regulations are imposed can't be enforced worldwide without intrusive surveillance, any more than the drug laws can or the tax laws. Whatever can be done will be done by someone, somewhere. And that's a nightmare. Whereas an atomic bomb can't be built without conspicuous special purpose facilities that can be moderated by the International Atomic Energy Authority, biotech involves small-scale dual-use equipment. And the rising empowerment of bio-savvy groups will pose an intractable challenge to governments. The global village will have its village idiots, and their idiocies can cascade globally. Measures to keep us safe will aggravate the tension between freedom, privacy, and security. And these same concerns stem from the most hyped transformative technologies like robotics and AI. These have been discussed by other speakers. But what if a machine develops a mind of its own? Would it stay docile or would it go rogue? Futuristic books portray a dark side where AI gets out of its box infiltrates the Internet of Things, and pursues goals misaligned with human interests. Some AI pundits think it'll be a long time before AI will worry us more than real stupidity, and that we should worry more about breakdowns and bugs than about being outsmarted. But others take this seriously. The visionary futurologist Ray Kurzweil argued in his book, The Age of Spiritual Machines, that humans will transcend biology by merging their brains with computers. But to digress slightly, he's worried that his nirvana may not happen in his lifetime. So he wants to be preserved until it's reached. And there's a company in Arizona which will freeze your body and store it so that when immortality is on offer, you could be resurrected or your brain downloaded. I was surprised to find that 3 academics in England had gone in for this cryonics, and 2 have paid the full whack, and the 3rd took a cut price option of just wanting his head frozen. I'm glad to say they were from Oxford and not from my university. I told them I'd rather end my days in an English churchyard than an American refrigerator. For the rest of my remarks today, I'm going to focus on space technology. It's already pervasive. We depend on it daily for sat-nav, communications, and weather forecasting. And it's in space, a hostile environment for humans, that robots have the greatest scope and will raise the fewest problems. During this century, the whole solar system will be explored by swarms of miniaturized probes with AI capability, and robotic fabricators will assemble large structures, for instance, giant telescopes or solar energy collectors in space or on the moon. What about human astronauts? The moon landings over 50 years ago, ancient history to the younger generation, are still the apex of human spaceflight. Will there ever again be inspirational Apollo-type projects? NASA's astronaut programs ever since Apollo have been impeded by public and political pressure into being extremely risk-averse. Because of this safety culture, NASA will confront political obstacles in achieving any grand goal within a feasible budget. NASA's Artemis project imagines a return to the moon by 2030. Sending humans to Mars with 6 months of provisions for the journey and supplies for the return journey is immensely more costly and hazardous than going just to the moon. I argued in a recent book that human spaceflight, if done at all, should be private enterprise ventures by Elon Musk's SpaceX and Jeff Bezos' Blue Origin. They can operate a cut-price program far riskier than Western governments could impose on publicly supported civilians. But it's a dangerous delusion to think that space offers an escape from Earth's problems. Dealing with climate change on Earth is really simple, a doddle compared to terraforming Mars. There's no planet B for ordinary risk-averse people. Elon Musk's concept for a city of 100,000 ordinary humans on Mars is, of course, wildly futuristic. But if Musk had a few hundred Starship rockets, which he could then launch one per day, each stacked with 10 or 20 robots, plus batteries, etc. So within his lifetime, there could well be many thousand robots doing construction, mining, or exploration projects, wandering around on Mars each more capable than the best humanoid robots we have now. It's unlikely that many humans would actually wish to spend their lives on Mars as it is. But one megalomaniac human would, and that is Elon Musk himself, who has said he would like to die on Mars, but not on impact. So he could task the regiments of robots with creating a domed mansion to accommodate him in his last years, and his body could then be preserved in a massive mausoleum that would last for millions of years. The history of human technology is measured in millennia at most, and it may be only 1 or 2 more millennia before humans here on Earth are overtaken or transcended by inorganic intelligence, which could then persist, continuing to evolve on a faster than Darwinian timescale for billions of years. Organic human-level intelligence would be just a brief interlude before it takes over. Few doubt that machines will advance on present-day AI and will gradually surpass more and more of our distinctively human capabilities. Disagreements are basically about the time scale, the rate of travel, not the direction of travel. The cautious amongst us envisage timescales of centuries rather than decades for the transformation from humans. And of course worry that a technological apocalypse could devastate our planet and foreclose such scenarios of self-sustained post-humans before intelligence has spread beyond the Earth. Be that as it may, the timescale for technology to advance is but an instant compared to the timescales of Darwinian evolution, which have led to humanity's emergence over several billion years. And more relevantly, those timescales are less than a millionth of the vast expanse of cosmic time that lies ahead before the sun dies. So we are perhaps near the end of Darwinian evolution via natural selection, but a process of technological evolution is only just beginning. Evolution of flesh and blood humans could happen fastest if there were, for instance, a population of humans on Mars who had a great incentive to modify themselves, but still it would be much slower than electronic intelligence could modify itself. I'm an astronomer, and one of our greatest discoveries in recent decades has been that most stars orbited by retinues of planets. We therefore expect literally millions of planets in our galaxy, resembling the Earth in being the same size as our Earth and warmed by a central star like the Sun to a temperature where water can exist. These planets are deemed to be habitable, but does that mean they are inhabited? This key issue may soon be clarified. The origin of life is a topic that's now attracting stronger interest. It's no longer deemed to be one of those problems which, though manifestly important, are relegated to the, as it were, too difficult box, because it doesn't seem timely or tractable. The understanding of life's beginnings is, of course, important not just for our assessment of the likelihood of alien life, but also to enlighten the most firmly earthbound evolutionary biologists about how our own biosphere began. Even in a complex biosphere, the emergence of intelligence isn't guaranteed, nor even perhaps likely. If, for instance, the dinosaurs hadn't been wiped out, the chain of mammalian evolution that led to humans might have been foreclosed, and we can't predict whether another species would have taken the lead. Some evolutionists, for instance, Stephen Gould, argued that the emergence of intelligence is a real contingency, a rare contingency indeed. Suppose, however, that there are many other planets around other stars where life began, and suppose that on some of them, Darwinian evolution followed a track that led to technologically capable creators. Even then, it's highly unlikely that the key stages will be synchronized with those here on Earth. If the emergence of intelligence on a distant planet lagged sufficiently behind what has happened here on Earth, then of course that planet would plainly reveal no evidence to us of ET. But on the other hand, a planet around a star 1 billion years older than the Sun could have had a head start of up to 1 billion years on us, and its manifestations now would be quite incomprehensible to us. So, if ET were common, wouldn't some have evolved around stars older than the Sun and had this big head start? This is a worry to some people because of what's called Fermi's paradox, which is that if there are all these aliens, why haven't they visited us already? Dozens of potential solutions to this paradox have been suggested, and Mario Livio and I have proposed another one. Suppose there are indeed many other planets on which life began. Around a star older than the Sun, life could have had a head start of 1 billion years. Darwinian evolution favors aggression. Humans are expansionists. But these electronic entities, post-humans, will evolve by what would be called secular intelligent design. Machines designing better machines, not by Darwin's struggle for existence, which favors aggression. So they may be leading contemplative lives rather than being expansionists, and they could exist in vast numbers without us being aware of them. Though, of course, they may be aware of us. They may prefer a zero-gravity environment, especially for the construction of massive artifacts. So it may be in deep space, not on a planetary surface, that non-biological brains develop powers that humans can't even imagine. But what about consciousness? Is this a special property associated only with organic, wet brains embedded in a flesh and blood body, such as humans, apes, and dogs? Could it be that electronic intelligences, even though they are more than human in their properties, will still lack self-awareness or an inner life? Or is consciousness an emerging property on any sufficiently complex network? This is a very live debate among the experts. Some say, though, that this question is irrelevant and semantic, like bothering about whether submarines swim or not. I don't think it is. Indeed, the issue is being debated urgently because some believe that the LLMs, large language models, could approach human-level general intelligence by the 2030s. We may decide that computer systems then deserve rights, or we may say that they're not conscious despite superhuman competence in most intellectual tasks. So this issue crucially, but of course far less urgently, affects how we react to the idea of the far future scenario that I've sketched out. If the electric aliens, which are our remote successors, are zombies, we would not accord their experience the same value as ours, and the post-human takeover would seem rather bleak rather than something we could aspire to. On the other hand, if they're conscious, we should surely welcome their future takeover. And there's a lesson here for today's scientists. We should surely be open-minded about the likelihood that there's much we don't understand. Indeed, that our species may never understand. Human brains have changed little since our ancestors coped with the challenges that life presented at the dawn of humanity on the African savannah. It's surely remarkable that these same brains have allowed us to make sense of the quantum and the cosmos, far removed from the common sense everyday world in which we evolved. Scientific frontiers are advancing fast. Answers to many current mysteries will surely come into focus, but human comprehension may sometime hit the buffers. There may be phenomena crucial to our long-term destiny that we are not aware of, any more than a monkey understands quantum theory. And physical reality could encompass complexities that neither our intellects nor our senses can grasp. Future AI systems may have a quite different perception of reality, nor can we predict or understand their motives. That's why we can't assess whether the great silence, the lack of evidence for aliens, signifies the absence of post-humans from other worlds, or simply their preference. If we detect something manifestly artificial, what might it be? We've heard about this in earlier talks. Conjectures about artificial life are, of course, far more shaky than those about simple life. I'm not an expert, but unlike in exoplanets and biochemistry, there aren't any real experts, so I feel less diffident. Indeed, science fiction writers can perhaps enlighten us more than academics. But I'd venture to speculate just 3 things about what could be revealed. I think they will not be organic or biological. Aliens will not remain on the surface of the planet where their biological precursors lived, and we won't be able to fathom their motives or intentions. Few doubt that machines will gradually surpass more and more of our distinctively human capabilities. Disagreements are basically about the timescale. The cautious amongst us envisage centuries rather than decades, and of course worry that a technological apocalypse could devastate our planet and foreclose all these scenarios before intelligence has spread beyond the Earth. But we just don't know, because in any case, this is about a millionth of the vast expanse of time lying ahead. So we are perhaps near the end of Darwinian evolution by natural selection, but the process of technological evolution of intelligence is only just beginning. Evolution of flesh and blood humans could happen instead, and could happen fast if there were a population of humans on Mars. This scenario means that even if life had originated on Earth, it need not remain a trivial feature of the cosmos. Indeed, humans may be closer to the beginning than to the end of a process whereby ever more complex intelligence spreads through the galaxy. The leap to neighboring stars is just an early step in this process. Interstellar voyages, or even intergalactic voyages, would hold no terror for near immortals. So perhaps the galaxy is teeming with advanced life, and our descendants will plug in to galactic communities as rather junior members. On the other hand, Earth's intricate biosphere could conceivably be unique, or unique in our galaxy. And the searches for SETI may fail. This would disappoint the searchers, but it would have an upside because humans could then be less cosmically modest. Our tiny planet, this pale blue dot floating in space, could then be the most important place in the entire cosmos. Either way, our cosmic habitat seems tuned to be an abode for life. Even if we are now alone in the universe, we may not be the culmination of this drive towards complexity and consciousness. Finally, just some closing thoughts that bring us back to our present day. This pale blue dot in the cosmos, which is our habitat, is a special place. It may be a unique place. It's existed for 4.5 billion years, and its potential future is even longer. But we're its stewards at a especially crucial time. We're deep in what's called the Anthropocene. And that's an important message for us all. We need to think globally, we need to think rationally, we need to think long term. We need to be, as it were, good ancestors, empowered by 21st century technology, but guided by values that science itself can't provide. Thank you for listening.
So Nico, is Professor Rees joining us now live by Zoom? No. So later, right? Yes. So questions, of course, only for Liviatan.
So do we have a
The stage is only yours.
A question and a half.
We have a question over here.
I just wanted to say.
It's over here.
Listening to what Professor Rees just listening to what Professor Rees said, I want to say that finally, I know that I said it doesn't transform us, but I think what it does, it keeps the desire structured, desire in the sense of wanting to go further. And this is why I think all this is very important to this search into other planets or whatever, interstellar or whatever. I think this is the reason why, we have to go on looking into that, because it keeps the desire us unfinished. That's what we need. Human beings need to be unfinished.
Thank you. There was a question just over here.
Thank you very much. That was most interesting from both speakers. But I have a question for you, Ms. Liviatan, and that is the legal aspect is, of course, of immense importance. And we've been watching closely the European aspect of it and how it tries to regulate it. But from what we were seeing, and I think it was mentioned for most of our speakers now, it's a medium that it's, if I can call it a medium, which is fast moving forward. It expands in an amazing, fast way. It transcends limits, geographical limits, even time limits, which means that we need measures that are analogous, similar to what it is, in order to address the problems that it might create. And it seems to me that our legal systems don't have those features. They are country-specific. We have international accountability, but do we really? we have a time limit. Lawmakers take a long time in order to decide, and we've seen it in the European Union. So my question is, do you think, or is it in the cards for lawmakers to actually take advantage of AI itself in order to make it, or ask it, or whatever is the way we communicate with it, to set its own legal limits, to set up its own red flags, and actually have these enforced internationally, country by country, or in the international system itself? I don't know, how do you see this?
Thank you. This was an excellent question. So firstly, let's look historically at law. We actually did amazing things, and what brought us to do amazing things internationally was inventions that we are worried about. So the atomic bomb is one invention that brought the entire international post-1945, what we have today as the UN, as the World Bank, as the IMF, the International Monetary Fund. It's all post-1945, it's all post the atomic bomb. But that's not the first time. The Industrial Revolution, where people lost jobs, actually brought unionization to the entire world. So we have done amazing things with law. It's true that law works slowly. It's not a bad thing that law works slowly, because you can fix and you can mitigate and you can amend. And I think one of the difference between the Oracle of Delphi and the oracles of today, which are the AIs that we all look for our answers, is that the Oracle of Delphi, I don't have to tell you, spoke in double speak. He didn't say to you exactly what's happening. And that created a conversation around the prophecy. Now, I think, the eminent astronomer quoted Yogi Berra. Actually, if I recall correctly, that quote belongs to Niels Bohr, who was a scientist, and he said predictions are hard, particularly about the future. And the oracles gave us hard predictions, but it gave us the agency to do something about it. A tool can help you do many things. So if the LLM has the answer to do it better, you can use any tool you need. But law is a conversation in a society. It's not an LLM that will create that conversation. It's us creating it in citizens' assembly, in things along those lines. And you see that are actually coming up in the world today. Those citizens' assembly that you have created many, many years ago are now mushrooming all over the world, and a lot about AI as well. So I have full belief in our agency as humans, not as machines.
There's now 3 questions.
Okay.
No, we'll take just one. Just pick one. And, you can save your questions for the round table discussion.
Okay, over there.
Thank you very much for your very interesting presentation. The case you present for legislation for regulation of AI makes me think of the debates in the 80s and 90s on the regulation of genetic engineering and biotechnology. It was still a new technology with risks had to be still assessed properly, and there was what was then taken up by the legislators worldwide, US and the EU, was the principle of the precautionary principle. You try and regulate before, to some extent, to regulate the technology. There were still the same arguments as today. What I'm getting at is then there was some basic regulation, although it's been deregulated since. But the pressure in order to pass the regulation was civil society and consumers who were very concerned, and civil society was concerned, which, as I see today, this does not exist in a similar way for AI. AI has come into everybody's life, even young generations, through iPhones, through the technology, the internet, and so on. So if there is no pressure from civil society and no pressure from consumers, how do you hope to regulate?
So,
thank you.
Thank you. It's a great question, and I am actually much more cautiously optimistic than you. I teach at Harvard. I started a class about social dilemmas in 2024 based on the eruption of ChatGPT into our lives. We didn't have anything, any conversations then. I'm looking back, only 2 years. My students today want me to ban AI in class, want me to take off their phones. They are worried, very worried about cognitive de-skilling, about offloading to AIs, never skilling. I see the conversation, we can look at, we can be half glass empty, half glass full, or be a realist. It's a glass it's never going to be a full. But what we have agency as people to do that conversation. So from here, you can start a conversation about that and think together. But I see the younger generation increasingly worried and doing things about it.